Okay,
Excellent.
so it looks like we can go ahead and get started, everyone. So my name is Christine. I am a second-year MPH epidemiology student here at the College of Public Health. Hope everyone is having a good morning so far. If you're comfortable with it, please feel free to turn on your cameras. We want our speakers to feel as though they're presenting to an audience today. As a reminder, we want to let everyone know that this is an interprofessional event with students from various disciplines and not just the College of Medicine. So today I'll be introducing Dr. Lisa Doggett and Dr. Donald Williams. Dr. Lisa Doggett is a family physician and has advocated for policies to reduce air pollution and climate change, worked to increase healthcare access, and launched the first environmental health elective at the University of Texas Dell Medical School. In addition to this talk, she is also a keynote speaker with the topic of mobilizing for change, how to be an effective advocate. She enjoys traveling with her husband, Dr. Don Williams, and their 2 teenage daughters. Dr. Donald Williams is a pediatric hospitalist at Dell Children's Medical Center in Austin, Texas, and an assistant professor of pediatrics at Dell Medical School at the University of Texas in Austin. He is board certified in pediatrics, pediatric hospital medicine, and internal medicine. He is married to Dr. Lisa Doggett and has 2 teenage daughters. So please welcome Dr. Doggett and Dr. Williams.
Can you hear me?
Yes, it's working perfectly for me.
Okay, yeah, we're having a little bit of technical difficulties, but hopefully we got it down. I just want to make sure the volume is okay. And I'm not sure let's see, where am I showing up on this? I'm not showing up at all on the screen.
It looks like the camera's off,
you know what,
but the mic is on and the screen is being shared.
Okay, can you still hear me okay?
Yes, and cameras also are working perfectly.
Okay. Oh, you know what? I can't hear them, but you can.
All right, we're gonna go ahead with the other computer and make this work. Okay, and you can still see me. Don, you wanna say hi real quick?
Hello, I'm Don Williams. Sorry about the technical difficulties, but let's start it up.
All right, cool. Well, Don and I are really excited to be here with you all and appreciate you're taking the time part out of your morning to talk with us. Thanks for that nice introduction. It's nice to be here with Don doing this presentation together. Let me go back into, let's see, presenter view. All right, here we are. And I'm not in presenter view. There we go. Okay. I will tell you all just right up front that this is not a happy topic, and you may end up like us feeling a little bit anxious and paranoid if you weren't already after yesterday's presentations. But hopefully my next talk coming up later today on advocacy will help you feel a little more hopeful and empowered. So our objectives today are to discuss the health implications of air pollution, the components of air pollution, what are we talking about? And we talk about pollutants in the air. We're going to also hone in a little bit on fossil fuels and wildfires. We'll also talk about the health impacts of water pollution, discuss fracking and natural gas, review the challenges of studying environmental health, and particularly discussing the story of lead. And finally, talk a little bit about the physician's role and the health professional's role in environmental health, because we're not just talking about physicians here. But let's start with the quiz. So which of the following are true? And if you're able to throw some answers into the chat, that's great. But we will kind of just go through each one of these. So first, pollution is primarily a concern in large cities and developing nations. Because it's hard to control an exposure connect an exposure to a negative outcome, we can't estimate the health impacts of pollution. Air pollution is linked to lung problems, but its connection to other health problems isn't well established. Fracking for natural gas is a safe and healthy strategy to reduce air pollution and climate change. All of the above, none of the above. Can you see the chat? We're working on it. All right, I'm seeing some answers coming on the chat.
F.
F is right. And that seems to be the resounding answer here. But I will say that there's a little bit of truth to most of these answers. It's not really simple. It's actually quite complicated. So let's dive in and try to explore these a little bit more. So why are we focusing on pollution? Well, I love this quote from the Lancet Commission on Pollution and Health in 2017. And what they said is, for decades, pollution and its harmful effects on people's health, the environment, and the planet have been neglected by governments and the international development agenda. Yet pollution is the largest environmental cause of disease and death in the world today, responsible for an estimated 9 million premature deaths. You think about how much of a fiasco the COVID pandemic has been, but there's only been about 5.8 million deaths from COVID during the entire pandemic. So we're talking about more than double the pandemic deaths, or rather, on an annual basis, we're talking about way more than COVID, even over a 2-year period, related directly to pollution. So the artist Claude Monet is well known for his impressionist paintings, including a series he painted of the London Houses of Parliament in 1904. What's interesting about these paintings is that some environmental scientists who have studied his work believe that the paintings actually show a more accurate depiction of weather conditions, including air pollution, which was then been realized in the past. Air pollution in London at this time was a huge problem. It actually was a big problem throughout the 19th and at least the first half of the 20th century. In 1952, it became much more clear, though, what the impacts were on health. Before this time, we really didn't realize what a big impact air pollution was as a contributor to poor health outcomes. But in 1952, in December, there was the Great Smog. This was due to a combination of industrial pollution and high pressure weather conditions, and it led to 5 days of dangerously polluted air. Fortunately, some scientists at the time actually studied the connection between smoke and deaths. And what they found is that there was 7 times the usual rate of deaths from bronchitis and pneumonia during that time. The death rate in London's East End actually increased by 9 times what was expected, and as many as 12,000 people died directly from air pollution. So what does air pollution look like today? Well, the World Health Organization estimates that it's about 7 million people die each year as a result of exposure to air pollution. Approximately 5% of deaths every year are directly linked with air pollution. And a 2021 study showed that fossil fuels cause 1 in 5 premature deaths, which is over 8 million deaths. It's not an exact number here, but we know that the toll is quite large. 9 out of 10 people breathe air containing high levels of pollutants, which probably includes all of us living in cities. Low and middle income countries, though, of course, have the highest exposures from both indoor and outdoor air pollution. This is a photo that I took in 2016 of the Great Wall of China. I was fortunate to travel to Beijing and hike the Great Wall, which is an amazing place. But you can see that the pollution was incredible. And this was unfortunately how it looked most days when we were in Beijing. Air pollution in the US is a problem, though, as well. We think about China being, a really polluted place, but the US isn't doing super well in a lot of places either. An estimated 107,000 premature deaths each year are attributed to air pollution in the US, and about 40% of us live with polluted air. People of color are 3 times as likely to live in the most polluted places. And you'll see that this is a common issue, a big disparity, kind of a theme throughout a lot of these environmental issues that we discuss, is that people who are in low-income communities, people of color, are often at a disadvantage. So what are we talking about when we talk about air pollution? What are the types of air pollution? Well, there's multiple components of air pollution. There's the criteria pollutants, and these are actually regulated by the Environmental Protection Agency, the EPA, under the Clean Air Act. These include nitrogen oxides, sulfur oxides, photochemical oxidants in ozone, carbon monoxide, particulate matter or soot, and lead. There are also other toxic air pollutants that aren't regulated under EPA's Clean Air Act, and these include mercury and VOCs, or volatile organic compounds, And then finally, there's carbon dioxide, which in and of itself is not something that's going to cause health problems directly, but of course, over time, it's a huge pollutant when you think about its contribution to climate change. There are other greenhouse gases as well. So we're going to go through these, one or two at a time, and I'll focus first on nitrogen oxides and sulfur dioxide. These are formed and released when coal is burned. They have multiple health impacts, directly toxic to the lungs, but nitrogen oxides also combine with VOCs to form ozone, which has other impacts. These are also a major component of acid rain, and they combine to form particulate matter. So really, a lot of these air pollutants are kind of in and of themselves problematic, but then they also they're combined with other things to create other forms of pollution that are problematic. So now on to ground level ozone. This is the most pervasive outdoor air pollutant in the US. When you hear about those ozone action days, that's what we're talking about. It's formed when VOCs and nitrogen oxides are combined in the presence of heat and light. So of course, those ozone action days are usually more common during kind of late spring and summer months. The primary sources of ozone are motor vehicles and power plants. And this is, of course, a major component of smog. And certainly we see that quite a bit in our large cities, especially in Texas and West and East Coast. The effects include respiratory symptoms, susceptibility to respiratory infections, as well as increased risk of hospitalizations and early death, and increased asthma exacerbations. So it was thought for a while that it was really that air pollution was a problem for people who had pre-existing lung disease. But what we've learned over time through a series of studies, and this has been confirmed many times over, is that ozone may actually cause asthma. This was a study in 2002, 20 years ago, published in The Lancet, that looked at 3,500 kids with no history of asthma who lived in 12 different communities in Southern California. There were 265 new diagnoses of asthma during the 5-year period. And children who played at least 3 sports in areas with high ozone were more than 3 times as likely to develop asthma as kids who didn't play sports. This is an example of a study that really, I think, did a pretty good job of showing a connection between air pollution and health impact. Particulate matter. This is a harmful mix of small and solid particles. It's directly emitted from coal burning, and it's a major respiratory irritant. It's associated with cardiovascular events due to inflammation, and higher levels have been linked to increased mortality. This is a huge issue throughout many, many parts of the world. Recently, there have been several studies that have come out. This is one from last year or 2020 that showed even short-term exposure to air pollution, particularly the particulate matter, increases the risk of heart problems, especially in older people. There's actually a more recent study that showed that over 143,000 deaths could have been saved just by slightly strengthening the federal limits on particulate matter. So particulate matter, again, even just doing a little bit can make a big difference. It's very, very problematic from a health standpoint. So what about COVID-19? What are the air pollution impacts? Of course, there's always a connection to COVID these days. What we've learned is that both short and long-term air pollution exposure may increase the rates of COVID-19. There's also been an increased risk of dying from COVID-19 that we've seen for people that are exposed to higher levels of air pollution, about a 9% increase in death. There's also been an impact from the pandemic on air pollution itself. And this has been kind of one of the silver linings of the pandemic. We've actually seen better air quality during the pandemic's first year in many parts of the world. The lockdowns reduced nitrogen oxide, nitrogen dioxide, as well as particulate matter by about 60%, 31%, respectively, in 34 countries. There have been mixed effects on ozone. And the findings, to me, really indicate the potential for reducing health risk by lowering air pollutant emissions from economic activities. So we really can make an impact. We do make an impact. We didn't want to have this happen with the pandemic, but it does show that we have the capability when we reduce transportation and other emissions to improve air quality. Wildfires. I know you all are aware of the terrible fires that we've had the last few years. In fact, 2020 was the worst fire season on record in the United States. There were over 10 million acres that were burned. 1 in 7 Americans experienced dangerous air quality due to wildfires. And the California impact was huge. There were, 31 deaths, over 10,000 buildings were destroyed, over 4 million acres burned. And there is certainly short and long-term health impacts, including that increased risk from COVID. Unfortunately, the 2021 season wasn't much better. There were almost 7.7 million acres that were burned. So one of my questions at the beginning of the talk was about health implications of air pollution. And I think one of the things that's been interesting to me is learning that air pollution really does impact way more than just the lungs and even than the heart. And this is another question, but I'll go ahead and tell you it's all of the above. Air pollution impacts bone mass. We've seen increased osteoporosis linked with air pollution, increased risk of miscarriages, dementia, Parkinson's, glaucoma. There are so many body systems and organs that are impacted by air pollution. So I mentioned environmental justice issues. This is just a story of one of those an example of true environmental injustices. Blacks and Latinos are far more likely to live near landfills, power plants, concrete mixing facilities, and other sources of air pollution, and they're more likely to die from air pollution. This example of Shingle Mountain is really unfortunate. There were these shingles that started being dumped in South Dallas in 2017. Illegal research or recycling, an operator started spewing these toxic chemicals and particulate matter. The neighbors complained about it. People were getting sick. And it took years, literally years, for them to actually finally start a cleanup of this area. And it was finally approved in 2020 after a long legal battle. All right, so let's move on to water pollution. It's a little bit shorter. Water is uniquely vulnerable to pollution. So it's able to dissolve more substances than any liquid on Earth. It's really part of the reason that water is so problematic is because of the fact that it moves, it can dissolve lots of things, and it often doesn't have the potential to kind of clean itself the way air does to dissolve into the atmosphere. And so water pollution is certainly a major issue globally. The need for clean water, of course, continues to increase. And yet pollution occurs when the harmful chemicals or microorganisms contaminate a body of water, reducing quality and makes it toxic for humans and the environment. 80% of wastewater in the world is dumped back into the environment, rivers, lakes, and oceans without adequate treatment. So we are continuing to contaminate water. And almost half of US rivers and streams and a third of lakes are unsafe for swimming, fishing, and drinking. So what are the sources of water pollution? Nutrient pollution is a big one. This is due to agriculture. This is one thing. I actually just saw a really excellent little film about this today from the New York Times about big agriculture's contribution to water pollution, as well as air pollution and climate change. Nitrates, phosphates from fertilizer runoff, and farm waste are major contributors to water pollution. Pesticides also from big ag are a big contributor. Municipal and industrial waste, heavy metals, plastic. We hear a lot about plastic pollution recently, as well as oil spills and leaks. And finally, trash from industry and individuals. So true or false, I would love to see your answers in the chat. We should all switch to bottled water. What do you think? False, 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 false. Okay, all right, I hear you. I don't disagree with that, but it's complicated. So most US tap water is regulated and safe, but unfortunately millions to water safety rules are common. There was a report by the National Resources Defense Council that showed 77 million people in the US live in communities with water safety violations in 2015. So this is potentially problematic that we can't completely trust the water. Some contaminants aren't even controlled, but bottled water may not be safer. So bottled water is not as carefully regulated. It may contain tap water, and just be the same thing that you're getting, except now you're creating plastic pollution and you're creating, again, that excess waste. So I took a look at Oklahoma City's tap water, and this is actually an excellent resource. I have the link here, but it's the Environmental Working Group that does a review of tap water contamination. And according to the EPA, the tap water from Oklahoma City's water utility is in compliance with federal health-based standards. This was last done in 2021. So that's good news. That's not surprising. But there still are contaminants detected. So there were 11 different contaminants found in the water, according to Environmental Working Group. On the website, you can actually see the different contaminants listed, and many of them are potential carcinogens, which is a little scary. Probably not at huge rates. I would say the water is probably pretty safe. But I'll also tell you that in doing this talk over the last couple of years, I've become paranoid enough about the water here in Austin that we now have filtered. We have a filter, and we had it installed to our sink and drink filtered water, which is makes things a little bit safer, but without the plastic solution pollution and having to buy unsafe bottled water potentially. All right, so I mentioned the agricultural industry. This is really a problem. It's a major source of both air and water pollution. It accounts for about 15% of premature deaths caused by particulate matter emitted by fertilizer and manure. Corn production alone is responsible for about a quarter of such emissions. I know this is a big deal in Oklahoma and certainly something for you all to be aware of. It's also a leading cause of water degradation worldwide. So health impacts of water pollution are significant. The water pollution is linked to about 1.2 million deaths. I've seen higher rates than that listed elsewhere, but we know that definitely over 1 million people die every year as a direct consequence of unsafe water. Water also causes a lot of people to get sick. In fact, about 1 billion people a year get sick from unsafe water. Low-income communities, again, are disproportionately affected. So what are the specific health impacts? Well, waterborne pollutions from animal and human waste contaminate drinking water and cause illness. Cholera, giardia, typhoid, Legionnaire's disease, these are some of the more common illnesses that are problematic, as well as swimming in polluted water. I was reading last night that about 3 to 8% of people that swim in a natural body of water will actually get some kind of sickness from, or rash or something from that exposure. Pretty significant. But about 3.5 million Americans each year will end up with something like a rash, conjunctivitis, respiratory infections, hepatitis from contaminated water. All right, and with that, I'm going to turn things over to Don.
All right. Okay. Thank you very much, Lisa. Great info. And thanks everybody for spending your Saturday morning with us. Just a quick question. We end at 9:50. Does that include questions, or is questions afterwards?
It does include time for questions, but if we don't have time for that, then it's okay too.
Got it. Okay. All right. So all right. So I know it's hard to remember a lot of facts from a talk. So what I'm hoping to do today is discuss basically 2 topics, natural gas and lead, and then make a few points that can be generalized to other topics in environmental health. And hopefully they can add to the way you think about it. So the first point I wanted to make is that environmental health can feel more difficult to be confident about than other disciplines in medicine. Health professionals like it when data demonstrate a clear effect, when they're trained to read patterns and be able to identify when something doesn't look right. But in environmental health, the effects we often see are subtle and common, and it's frequently difficult to separate the control group from those who are affected with whatever condition we're studying. And what's more, health professionals are usually not used to having people with different points of view publicly contradicting them. And so individual health, doesn't attract money and attention, but often the topics of environmental health do. And the stakeholders often have a very clear incentives to try to disprove you, even when they have very little data to do so. So that being said, let's jump into our first topic, which deals with energy policy, and in particular with natural gas. And you've probably heard people say that natural gas is a good bridge from fossil fuels to other sources of energy, such as renewables. And if you're like me, you've sensed that there's quite a bit of debate about whether or not this is true. So my question is natural gas a healthier solution to our energy needs than petroleum or oil? Well, to start, what is natural gas? Natural gas is mostly methane. Methane is trapped in underground rock formations that were thought for a long time to be inaccessible. But the process of hydraulic fracturing or fracking has revolutionized our ability to extract methane from deposits far underneath the ground. There are multiple technological innovations that included the ability to drill horizontally. And these have led to a 400% increase in the amount of natural gas production since 1950. Natural gas is often touted, as I said earlier, to be a cleaner alternative to coal and oil. And in a lot of ways, this is true because when you burn it, there's negligible particulate matter, mercury or sulfur dioxide, as you see with coal or oil. And indeed, there is less CO2 produced per energy unit created than coal or oil. So this is just a pictorial representation of what happens when new natural gas wells drilled. As you can see, the drill goes down through the water table, far down into the earth, frequently a mile or so underground. And there, the drilling goes sideways, usually through shale deposits. And then large amounts of water and chemicals and sand are injected at pressure. This breaks open the shale, and you can sort of see in the inset here that the sand in there keeps the fissures open, and that allows gas to escape, mostly methane. That methane travels back up to the surface where it's captured. So if this is cleaner, what's the problem? Well, Dr. Landrigan, a big name in environmental health, is quoted here by saying that gas is associated with health and environmental hazards and reduced social welfare at every stage of its life cycle. And yes, by the way, that is a picture of someone lighting their tap water on fire. This occurs when there's too much methane in the groundwater. Sometimes it's a result of fracking, but often it's actually just there naturally, a lot of methane, and you can sometimes see this phenomenon when private wells are not properly vented. So what is Dr. Landrigan talking about? Depending on, to some degree, on how careful the company doing the fracking is doing their job and how well government regulators are regulating, the practice of fracking is associated with some ground and surface water contamination, some air pollution, and as it gets a lot of attention, some small earthquakes. But to me, and this is really kind of the crux of the issue, the much more important part of this is greenhouse gas production. So the burning of methane produces, like I was saying earlier, less CO2 per energy equivalent than does the burning of coal or oil, about half to 2/3 as much. The problem is that, and Dr. Haley touched on this yesterday, or actually explained very well yesterday, that even with the best of care, some methane leaks out of the ground and into the atmosphere during drilling and capture. And methane is a much more potent greenhouse gas than carbon dioxide. In fact, it's got about 80 times the heat trapping potential that carbon dioxide has, at least in the short term. And generally, methane leaks are reported to be about 2% while drilling. And so the end effect of global warming potential for natural gas is at least double the amount created by just the CO2 alone. So that makes the greenhouse gas footprint of methane similar to, and in many recent studies, worse than coal or oil. So if the question is, does natural gas lead to less pollution than coal or oil? I think you have to ask, well, what do you mean by pollution? If you're referring to air pollutants like particulate matter, sulfur dioxide, mercury, then the answer is yes. Natural gas is less polluting. But if your question is about what I would consider the most existential threat to our planet, global warming, then I think you have to conclude that natural gas is no better than coal or oil, and it's actually probably worse. Just finishing out some of the health risks here. When you have the gas, you have to get it to places where you can combust it. And so when you transmit it and store it, you can get risks of fires, explosions. The compressor stations that exist for this emit toxic chemicals and are often in neighborhoods where people are poor. And the combustion produces NOx, which we talked about earlier, increases lung disease. Yet, push for natural gas continues, probably because of good lobbying on their part, a little bit because of maybe poor information on people's thoughts about the polluting nature of it. New gas permits are being issued, and under current policy, gas is set to get a lot more use than renewables through 2050. And government subsidies, your tax dollars go to support fossil fuels and continue their use. And fracking really is a continuation of the carbon-based energy system. Okay, so we're going to switch gears here and talk about another common theme of environmental health. And that is that we first recognize that particular chemicals or exposures have negative health consequences only in acute severe overdose. Only with time, high levels of suspicion and nuanced studies do we see that certain chemical exposures, often at low levels, have dramatic and long-lasting effects across the population. And this, I think, is perhaps best captured by the story of lead over the last century. So to start, let's talk numbers, particularly important for people who are not used to dealing with lead in patients. What level of lead in the blood is so high that it's considered unsafe? And you can enter that into the chat or shout it out. I don't know if I can. Okay, I think people are saying, some people are saying B. I like, some people are saying A. Good, thanks for the participation. So sorry to do this, and I don't like these trick questions, but this is a bit of a trick question because as of last year, the CDC stated that the only safe level in lead is no lead. So the only safe level of lead in the body, rather, is no lead. They reached this conclusion because research has shown dramatic differences in IQ, even at levels less than 5, a finding that we'll go over in a subsequent slide. The more interesting part to me about this question is that all of these answers, at some point in the last 50 years, were correct. This is what we considered a safe level of lead since the 70s. And going back to, this is a journal, a respected health journal, and I think it's just really, I'll take a second to quote it. Among lead industry workers, the acceptable upper limit of blood concentration is set at 70, but many reports claim that 60 is the upper limit that should be tolerated in persons with a known source of excessive exposure to lead. In a recent review of blood lead levels in various segments of the population, particularly children, it's been emphasized that 40 should be the maximum upper limit of normal. And for people who've done any work on lead in children, this is probably a fascinating quote to hear because it's really a different story these days. So how do we know that very high lead levels are bad? We know because there are some very obvious, serious symptoms that occur when you have very high lead levels, usually in people who become acutely toxic while working with lead. These include abdominal pain, headaches, anemia, and at very high levels, acute encephalopathy and potentially even death. But the true legacy of lead is not so much in the plight of the acutely poisoned, but rather in the subtle health problems of millions of children. So studies starting in the middle of the last century show that in addition to undermining IQ, low-level lead is associated with a wide range of adverse effects in cognition and behavior. Many of these effects or traits are associated with ADHD, like hyperactivity, impulsiveness, distractibility. Others include impaired reading, math, spelling, and other learning disabilities. And again, we're not talking about dramatic elevations of blood lead levels like you'd see with acute poisoning. In this, in a 2003 New England Journal article, it was shown that an IQ lost between a lead level between 1 and 10. So if you go from a lead level of 1 to a lead level of 10, the IQ lost was 7.4 points. Another study, which is the one on this slide here, showed that there was a 6.1 IQ point loss when going from a lead level of 0 to 5. And if you'll excuse the outdated terminology on this graphic on the slide, you'll see that when you have a 5-point IQ point loss across a population, that moves several million children from the quote gifted category into the intellectually disabled category, which is a really important effect on our whole society. So partly as a result of the increasing recognition of the long-term neurodevelopmental problems associated with chronic lead toxicity, the levels considered safe have dropped over time. This graph doesn't even, it doesn't include rather last year's change when the CDC announced that there was no safe level. And this, I think is one of the most iconic graphs in public health, and I think just again fascinating for especially for people like Lisa and I who grew up in the 1970s to realize just how much lead there was in the atmosphere. When I was born in 1973, there was approximately 1 kilogram of lead being released into the atmosphere per American per year in gasoline, which is just to me astonishing. And as I said, people started to realize that this was unsafe, and for a couple other reasons as well, started to phase out lead in gasoline in the 1970s. And there's not a legend on the side here for how much lead is in the gasoline, but this is the declining levels of gasoline lead in blue here. And actually that should level out toward the end, and it goes down to pretty much 0 where we're at right now. And the question is, what happens to the blood lead levels of children during that time? And I think this is really the astonishing part of what you see, which is that perhaps obviously blood lead levels in children go down, and it pretty much matches how much lead is in the atmosphere. This just shows again the dramatic decrease in the amount of lead in children's blood from the late 1980s to about 10 years ago. This doesn't even capture the height of the problem in the 70s, when the average blood lead level was about 16. But nonetheless, it does demonstrate that the problem doesn't affect people equally. And as we've seen for a whole host of problems that we've brought upon ourselves in society, effects are disproportionately severe on people of color. And this is certainly the case with lead, though thankfully, at least in this one instance, the problem is much improved for virtually everyone. In addition to the findings that are nearly universally accepted about the neurodevelopment of children, there's a host of other negative consequences that have been blamed on lead. There are data to suggest that it's responsible for much of the hypertension and cardiac disease we've seen in the last half century. And as this graph shows, there's speculation that behavioral health effects of childhood lead exposure directly led to an epidemic of violent crime, which is really kind of intriguing. Okay, I'm going to do a couple slides on Flint because this is probably a familiar story for most of us from the last 10 years. The story of lead in Flint is interesting to me, not so much because the individual blood lead levels, which were really in general much lower than the average lead levels in the 1970s, but rather for the lesson it teaches us about the importance of healthcare professionals in policy conversations. So just a real brief explanation. 2014, in order to save money, Flint changed its water treatment plant from Detroit to its own. And at that time, they stopped corrosion control for a variety of reasons. 2015, a year later, increased lead levels were found in the water supply and also in children's blood. And initially, the response from government officials was to deny and to sort of attack. And eventually, there was acceptance that this was real and apologies, and Flint ended up changing back to its original treatment plan. And again, highlighting this Dr. Mona Hanna-Attisha, who many people probably have heard of. She was a Flint-based pediatrician who exposed the lead crisis. She was studying lead in the hospital EMR and noticed that levels had doubled. Not surprisingly, she was by some people demonized, accused of causing hysteria. But ultimately, you know, her work was really a catalyst to get the state to mitigate the crisis. And you know, we probably, none of us would like it to be this way, but not everybody carries the same weight when they